Hello, everyone. I'm Luca Bello. I'm here to present the Canonical Observability Stack and how you can integrate it with your charms. So let's dive into it. Couple words about me. I'm a data scientist and software engineer from Italy. I started out my career working at CERN, the European Research Center for Nuclear Physics in Switzerland. And I'm currently living in Germany, and I'm part of the observability team at Canonical. In my free time, I like to do capoeira, play the piano, write about stuff, a bunch of things, really. Today, I'm going to talk about observability. So let me say a couple words about what that is. Observability is the ability to measure the internal state of a system by examining the outputs. And this is a term that comes from control theory. When we talk about it in IT, though, we oftentimes include the three pillars of observability, which are metrics, logs, and traces. Metrics are quantifiable measurements of something, usually the health and performance of applications and infrastructure. Logs are records of events, warnings, and errors, and traces is information about where your program is spending time in the code. So why do we need this? Why is this important? A number of reasons. First of all, alerting and monitoring. So for example, let's say you have an infrastructure with machines. A machine goes down. You want to know when that happens so you can take action. Service management, to take data-based action. Let's say you have an HTTP server that's going slow. You will want to know whether that's for a CPU bottleneck, RAM bottleneck, maybe there's too many requests, and so on. And of course, dashboards, which allow to do all of this and more by summarizing and aggregating data. This makes it useful not only for operations, but also for higher level decisions like business intelligence things. In general, though, this is all good, but it's a little problematic because the observability field has a lot of tools, lots of different tools, moving parts that are not so trivial to integrate with your system. And this is the exact problem that Juju and COS, the Canonical Observability Stack, try to solve to make this job easy. So what we're going to do today is that we're going to integrate the Zinc charm that you might have seen before a couple of times already with COS Lite by making it observable. So we'll add specifically 3 integrations with Prometheus for metrics, with Grafana for dashboards, and with Loki for logs. So feel free, by the way, throughout this presentation to write questions in the chat. We're here to answer, so please do. And we'll jump right in the code. So on this screen, you can see on the left the Zinc chart, which you might have seen a couple of times, as I said, and there's really not much to say about it. And on the right, you can see some notes that will guide both me and you throughout this demo. Let me walk you through the current setup I have deployed in Juju right now. This is the Juju status screen. You're going to see that I have pre-deployed to save time on the demo. I have pre-deployed Grafana, Loki, Prometheus, Traffic, and Zinc. So some basic cost components and Zinc. Nothing more to say about that. In the code, how do we start the integrations? So all the observability integrations, or most of them at least, require Juju library, Charmcraft library. So we're going to take the Juju topology library, and we're going to fetch it through Charmcraft because that's necessary for all the integrations. So let's do that first. So Charmcraft, fetch lib, charms, observability libs, v0 Juju topology. This will fetch the library, which is used to add topology information, useful things. And now it's been downloaded, so we can jump back and click the code. Okay, good. First integration is Prometheus. What do we want to achieve with this? So Zinc is naturally exposing some metrics already. If I jump to the browser real quick, you can see that these are the metrics that Zinc is exposing. So there is a metrics endpoint, a metrics webpage, where you can see information on Go garbage collection, memory usage, but also if I scroll further down, you can see Zinc specific metrics, like the duration for getting specific web pages, for example. We want to get all this information in Prometheus so we can use it in dashboards and all kinds of things, right? So let's go back to the code. You'll see that doing these integrations is very simple and straightforward. So for Prometheus and for everything, we'll start always with fetching the charm library. Charm library is called Prometheus scrape. So we'll jump out of the charm. We're going to fetch that library. So charms, Prometheus case, v0, Prometheus scrape. If I go back to the charm now, you can see that the library has been downloaded. It's right here, Prometheus scrape. Now I can move on to the actual integration. So first of all, we're going to import the metrics endpoint provider object. So from charms, Prometheus case, v0, Prometheus scrape, we're going to import metrics endpoint provider. All we need to do is to instantiate this object into the charm constructor. So we go down here. We can call this object however we want. I'm going to call it scraping. So metrics endpoint provider. And we need to pass a couple objects to this. First of all, the charm itself. Then the relation name, which I'm going to cover in a second. I'm going to call it metrics endpoint for now. And then the jobs. So these are Prometheus scrape jobs. The syntax, of course, is available and described much more in depth in the library itself or in the cost documentation, which I'll link to at the end of the demo. But for now, just know that what I'm typing is a very basic configuration to import or to say to Prometheus, scrape the main page. And that's pretty much it. So let me write this in. Okay, now that this is done, the code part's done. All we need to do is to add the relation to metadata. So let's go there. We need to add a provider relation. So we go down here, we add provides, and then metrics endpoint, which is a relation name, and then the interface is called Prometheus scrape. Now, what you need to note is that this metrics endpoint is the same metrics endpoint that you see right here. It's a relation name. Good. Now that we have this, we can move on to pack the charm, and we'll do just that. So I'm going to run charm grab pack. This is going to take 15 to 20 seconds. While it does do this, I can explain you what we're going to do. So we're going to refresh the Zinc charm with the newly built charm, newly packed charm. And we are going to relate that with Prometheus, and the metrics should appear in Prometheus. That's pretty straightforward, actually. So let's do that. We can Juju refresh Zinc. You're going to see that in the status screen, Zinc goes into a maintenance, and it's going to upgrade. And now that that has happened, we can run Juju relate Zinc to Prometheus. Before the application settle, that doesn't matter. Okay, now that everything is active idle and the application will settle in a second, what we're going to do now is we're going to go over to the browser again, and we are going to go to Prometheus, which I open here. And we're going to see that if we go to targets, the Prometheus targets, Zinc is going to appear right here. It's in red right now because Prometheus has not scraped Zinc yet. Prometheus does perform a scrape every 60 seconds. So if we wait a couple seconds and refresh, it will appear as blue. Just give it a moment. There it is. And you can see that Zinc is up. If I go to the Prometheus main page and I look for the metrics, like the up metric, which is the most basic one, we can see that Zinc appears right here. So the metrics for Zinc are appearing. We can also look for the Zinc specific metrics that we saw before, like request duration. They're all going to be here. So awesome. This is the Prometheus integration now. We would love to use these metrics for something now. like dashboards, right? Which is the reason why we'll move on to the Grafana integration. So let's go to the code again. Integration with Grafana is very similar. It's composed by two parts, the actual integration and adding the dashboard. So let's do the integration first. I'm gonna, again, fetch the Grafana dashboard library, which is needed for the integration. So I jump back, charmcraft, fetch lib, charms, Grafana Kate, v0, Grafana dashboard. Now that is being downloaded. We can go back into the charm. Similarly to before, we import an object, which is called Grafana Dashboard Provider from the library. So from charms, Grafana Kate, v0, Grafana Dashboard, we import Grafana Dashboard Provider. We, of course, need to instantiate this into the charm constructor. So we go down here. We call the object Grafana Dashboards, doesn't really matter. And the item is the object is a Grafana Dashboard Provider. Here we need to pass again a couple of things, but just two this time, only the charm and the relation name. It can be whatever we want, but it needs to match the metadata. Now the code part is done. We move on to the metadata again, and we add the relation itself to the charm. So we go to the provides, we add Grafana dashboard to match the relation name, and interface is Grafana underscore dashboard. Now that this is done, we can see if these two match. We need to add the dashboard, right? So by default, this is the folder of the charm. By default, the dashboard is going to be looked for in the source folder, in a Grafana dashboards folder that we can create here. This is, of course, configurable, but this is the default place where it happens. I'm going to show you what the dashboard looks like in a second. First of all, I'm going to create the folder, and I'm going to copy over a dashboard that I have already to not lose time. So if I go back to the code again, you're going to see that in this folder, the source folder, now there is a Grafana dashboard, which I just copied, and it looks like this. This is a JSON file, which is the standard format which you can export Grafana dashboards with. So if you go over to Grafana and you have a dashboard, you can export it to a JSON file and you can plop it right into this folder, and everything will happen automatically, will be imported in Grafana when you do Juju relate. Also, you can go to the Grafana marketplace and get a dashboard from there, and it's going to be a JSON file. And again, you can just put it here and everything will work out of the box. So let's close this. And now we can charmcraft pack and verify that what I said is actually true. So let's charmcraft pack. And while this does its work, again, what we're going to do now is we're going to refresh the Zinc charm. We're going to relate it to Grafana, and we're going to double check that Grafana has the Zinc dashboard, and that the Zinc dashboard is actually displaying something, since we have the Prometheus metrics as well. So the Zinc charm has been packed. We run Juju refresh. You're going to see again Zinc go into maintenance mode to upgrade. Okay. Now that it's back to active idle, we can Juju relate Zinc to Grafana. You're going to see here a new relation appear, Zinc Grafana dashboard to Grafana dashboard, which is the one we just added. And now that everything is settling down, we can jump back to the browser, open Grafana, look at the dashboards, and here it is, the Zinc dashboard. If we open it, you're going to see that we have data already. The HTTP requests per minute, you can see that the unit status is up. And yeah, the Grafana integration is done. You can see in this dashboard that if I scroll down, there is some data missing, which is logs. And why is this missing? Because we don't have the Loki integration yet. So you're going to see that now that we add the Loki integration, we're going to check back into this dashboard and logs are going to appear. So now that the Grafana part is done, let's jump back into the code one last time and move on to the Loki integration. Again, the process is extremely similar. We are going to fetch the charmcraft lib. So charmcraft, fetch lib, charms, Loki cates, v0, Loki push API. So now the library has been downloaded. We jump back into the code. Similarly, we import the library. This time the object is called log proxy consumer. So from charms, Loki cates, v0, Loki push API. From this, we need to import log proxy consumer. And we instantiate this object, self dot whatever, logging, log proxy consumer. What do we need to pass to this? You guessed it, the charm itself, the relation name, just like the other, log proxy. We need an extra param here, which is the log files. We need to tell the library which are the paths where the logs are going to be in. So I hard-coded this into a variable, so we're going to just pass that. Just know that this is the variable we're thinking is storing the log files. Doesn't really matter what it is exactly. So now the integration is complete. We need to add the relation to metadata as we've done before. So I'll jump back into that. This time it's a requirer. So we need to add a relation to the requires one, just because how the library is structured. Requires, it's already there, log proxy. And the interface is called Loki push API. Okay, now that this is done, we can jump to the charmcraft back. So let's do that. We can charmcraft pack. Again, this 15 to 20 seconds, we are gonna refresh the zinc charm and relate to Loki. So what will happen is that the logs will get to Loki in a little bit, and then Grafana is going to be able to see it, and we will see that in the dashboard. And I'll show you how you can have a look at those in Grafana. So the charm has been packed. We can Juju refresh sync. Think it's going to go to maintenance again. And it's going to upgrade. There it is. Now it's gone to active idle. We can Juju relate zinc to Loki. You're going to see here that Loki logging zinc log proxy relation over the Loki push API interface has appeared. Everything is active idle. Zinc is settling, or we can already move on to the browser. I'm going to show you first through the data sources view. So these are the data sources that Grafana has. Of course, Grafana has Loki as a data source. I can explore that. And so I can show you how the Loki data source looks like, because Loki doesn't have a UI. So this is the closest thing we've got. But I can show you that in the labels, if we select the Juju application, zinc is already appearing. And if I run the query, I need to zoom out a little bit. If I run the query, you can see that logs are there. So these are the logs that are appearing now. We have logs. We can zoom in on each log by like opening it and seeing like the single values. If I go back to the dashboard now, so dashboards, and I open the sync dashboard and I scroll down, you're going to see that we have data for logs now. We have log lines, debug logs, whatever. And for logs, I can still open one, look at all the informations, and you can do all the things you can do with Grafana. So like look for certain intervals of time, filter things, and such. So this is it really. As you can see, the integration with observability is extremely simple to perform. If I go back to the code again, you can see that all we've done really is to import 3 objects, 3 classes, and to instantiate them once in the constructor. And then everything just happens. So this is it. Some useful links. This is the cost documentation. The first one you see is the cost documentation, where you can find information on these integration, on more integrations like Tempo for traces, and all the information you need. There is a Charm Hub community discourse, which is linked right here, where you can join and read posts. And there is a Charm Hub Mattermost, specifically the observability channel, where you can just join and ask questions. So feel free to come in and ask questions. You can reach out in the observability channel or at me directly. And this is it.
My name is Ghislain Bourgeois. I'm a senior engineer here at Canonical, and today we'll be talking about using certificate providers with charms. So first of all, I would like to tell you to feel free to ask any questions you might have at any moment in the chat. There will be some of my colleagues available to answer your questions. So the agenda for this presentation is, first, we will be choosing where to terminate TLS. Then we will be adding the ingress support to Zinc8's operator. Then we will be testing those changes locally with the self-signed certificates operator. After that, we'll be deploying to production in AWS with Route 53 Acme operator to get real certificates. And then we'll be discussing other TLS providers in the ecosystem. So first of all, we need to choose where we will terminate TLS. And for that, we have a nice documentation page on Charm Hub where it tells you a bit how to use the different things in the TLS ecosystem with charms. So first of all, understanding your X509 certificates requirements, we have the first question: where should your TLS connection be terminated? So we propose at the ingress level if you are exposing a UI for users, where it enables you to provide access through an ingress to different applications. We also support adding at the app level where your application requires directly the certificates. For example, in the Postgres cluster that need to communicate over TLS, they each need their own certificate. So in that case, you would terminate it at the app level. So in our case, since we are exposing our UI to users, we will be using the ingress level for this presentation. So let's go here. We will be terminating at the ingress. So what we will be doing is your app here will be our Zinc8's operator. We will be implementing this new integration ingress that is supported by traffic. So we will be deploying traffic also, and it will expose the UI through its ingress interface to our users. And we will be relating traffic to a TLS certificates provider through the TLS certificates integration, and it will enable HTTPS over this. So first of all, we will be adding the ingress support to our Zinc8's operator. So to do that, we have 3 big changes that we need to do. The first one is to fetch the ingress library. So the ingress library is a charm library. And charm libraries are similar to a lot of Python libraries, but contrary to some of those on PyPy, well, most of those on PyPy, they are specific to charms. So they understand the charming workflow. They can interact directly with events from Juju and things like that. Most of them will be helping you integrate with different relations or integration points, like ingress in this case, or TLS certificates. Some of them will only be adding some features. For example, adding Kubernetes resources like patching a Kubernetes service or adding huge pages to a Kubernetes workload. So we will be fetching this library for the ingress relation that we want to use. We will then add the relation to the metadata.yaml to define that in our charm, and we will be updating the charm code to use that library. So let's get started with that right now. So starting from our previous point, let's first fetch our library. So this shouldn't take too long. It already created the library. So if we do a quick git status, it created a lib folder, and it will contain our library code. So now we can go in the metadata.yaml, and we can add the relation definition here. So first of all, we will add a require. So every relation in Juju consists of a provider and a requirer. The provider usually provides a certain service, and requirers are any charm that require those services. So in this case, we want our charm is requiring an ingress service. So we implement the require side. We will name the relation ingress, and it will be using the interface ingress. We will also add a limit of 1, so it can only be related once. So that's all for the metadata, and we can then change our charm code to add that library. So let's first get started by importing that library. So it's charm trafficates v2 ingress, and from that we will be importing the ingress per app requirer. From that, right now it's telling me that I'm not using it. Let's go to our init, and inside init we'll be just creating a parameter here. We'll be instantiating this ingress per app requirer. And as it's a charm library, the first parameter will usually be self. In our case, this is the charm itself, so it gets access to all the different events, relations, etc. So we're passing that. Then we pass a parameter named host. This one is for telling traffic where it can reach our application. So the name of the service that it will be able to find in Kubernetes will be self.appName, self.model.name, .svc.cluster.local. We will then be adding the port. The port is for 4080. So let's do a quick refactoring here. Let's add a variable. The zinc port is equal to 4080. Let's add this, and we'll change this one here to zinc port. And to finish, we'll add this strip prefix because traffic will be routing through paths. So it will be adding the path with the name of the application and the name of the model at the beginning of the path, and Zinc will be confused with that. So we'll ask traffic to strip that prefix. So with that, we, well, I made a typo here. That's why it is complaining. So requirer. And with that, we're done with the changes for the charm. So let's go back to our presentation. So now we're ready to test those changes locally with self-signed certificates. So we'll be doing all those commands to test it. I'll be going through those as a live demo. So let's go right over to our terminal. So first of all, we will be doing a charm craft pack to create our charm from the code that we just wrote. It shouldn't be too long because we already have built the charm before, and we just did some small changes. So it's doing that quite quickly. In the meantime, we can add our model. So let's add a model called Zinc. And now we're ready. We have our charm that is packed. We can deploy our Zinc charm. So in this case, we will be deploying the local charm file, and we have to pass the resource for the Zinc image, and that is defined in the metadata.yaml because we're deploying a local charm. Once this is deployed to CharmHub, it will use by default the image from the metadata.yaml. But in this case, we need to specify it. So while this is deploying, we can look at the status. We can then deploy traffic. So in this case, we will be deploying traffic directly from CharmHub. The channel will be Edge. We will be deploying it with Trust because it needs to talk to Kubernetes to create a load balancer resource. And we tell it its external host name will be test. So this will be used when asking for certificates. And in that case, I have this etc host entry for test. So while this is going on, we will be waiting for traffic to be fully deployed. So this is taking a bit longer because it is a bigger service. It also got the load balancer address on my local network. So now they're all active idle, so I can relate those together. So Zinc gates ingress to traffic. And we see that they're executing, so they're exchanging the information required to expose the service. And from there, once traffic is active idle, we should be able to do this quick test. And we see that we have a response, so we got access to that. But that was over HTTP, and it's not super interesting and super secure. So let's test our TLS right now. So first of all, we will be deploying this additional charm from CharmHub named self-signed certificates from the Edge channel. And we will be relating that one to traffic because we decided to terminate it at the ingress level. So the self-signed certificates is an implementation of the provider side of the TLS certificates interface, yes, and it provides certificates by generating self-signed certificates. So when it's deployed, it generates a CA certificate that is self-signed, and it signs CSRs directly. So this is great for internal cluster, things like that, development environments. So right now, this is done, this is related, so we should be able to do a curl with HTTPS. So I added this -k to my curl command here because the certificate is self-signed, so it won't be trusted. So with -k, it ignores the validation. We can also look into what the certificate looks like with the OpenSSL as client. And this will show us the certificate itself, how it's been signed. So right now we have a certificate for test, which is expected, and it's been issued by self-signed certificates operator. So that looks all good to us. So let's go back to our presentation. So now we will be deploying to production in AWS with Route 53 Acme operator. Here are the commands that will be running. The Route 53 Acme operator will let us get real certificates from Let's Encrypt using the DNS01 challenge managed by Route 53. So let's go to our interface here. In this case, I will be I already started some deployments beforehand with with traffic particularly, because it generates a domain name, and I already also created the Route 53 a CNAME entry to avoid any propagation delay issues during the presentation. So traffic is already deployed with this nicely generated name for the load balancer. We will be using, let's go here and look at the CNAME. So I already created this CNAME for traffic operator.inc.org, pointing to that name. So we will be able to use traffic.operator.inc.org for our use case. So traffic and the model is already done. So let's deploy our local charm again, the same thing as before, but this time we will be deploying that directly on AWS with our gem operator. So this is allocating. Once this is done, we will be able to relate it to traffic. Okay, so let's relate that. We'll see they're both executing again. Should not take too long to be done. And now we can go back here and look at the UI directly here. In our browser, we see that we have a non-secure connection because it's we're going through HTTP right now. So let's fix that. Let's fix that by deploying right now the Route 53 Acme operator. I'm deploying it with a config file. So the config file, you can find the details in the documentation for Route 53 Acme operator, but basically you require an email, your AWS access key, secret key, and the hosted zone of Route 53. So it contains secrets. I won't show that in this presentation, but I'm passing the YAML file for that. So you just need to fill out those information in your particular configuration file. So this shouldn't take too long to deploy. That's a quite small container. So now that it's deployed, we can relate Route 53 Acme operator to traffic again, because we're terminating TLS at the ingress level. And this time it will take a bit longer to generate the certificate, because with self-signed certificate, it's just signing the certificate directly in the charm code. But in this case, it needs to talk to the Let's Encrypt servers. It will get a packet challenge. It will update Route 53 and add a text record with that challenge response so that Let's Encrypt can validate that we are indeed the owner of that domain. So it's doing a lot more activity in the background, and we also need to wait a bit for the DNS propagation delay for that TXT record. So while it's doing its thing, it's telling us it's executing the Lego command. So in the background, it's using the Go Acme Let's Encrypt client. So that's called Lego. So it's executing that and doing all the communication with Let's Encrypt, with Route 53. And once everything is validated, we will get back the certificate, and the Route 53 Acme operator will provide it back to traffic over the relation. So we just have to wait patiently. It can take up to 5 minutes usually during this time. Now it's active idle, so we should be able soon, as we see traffic gates is executing now, so it received the certificate from the relation, and now it's active idle. So let's go back to our browser, and from our browser we should be able now to use HTTPS to connect to that, and now it's telling me it's an unknown issuer. Let's do a refresh. More information. Let's look at that certificate. So it's not the right one. Why is it not the right one? Oh, I don't have the right. I don't have the right URL. Let's fix that. Not sure why I didn't get the right URL from that, but let's enter it by hand. So operatorinc.org, and we should have the right certificates. Okay, and now we do have the right certificate, and we have the nice lock here. We see connection secure, verified by Let's Encrypt. If we take a look at the certificate itself, we see that it's for traffic.operatorinc.org. It's issued from the US Let's Encrypt organization, and it's valid for about 3 months. So we're pretty much done with this, and we have a real certificate that our users can now use and see that the connection is indeed secure. So let's go back to our presentation. So let's discuss now other TLS providers in the ecosystem. So as we saw before, we have the self-signed certificates operator that can be used for development environments, for securing internal communications between microservices that are managed together. So let's say you deploy a database cluster, and you want the network communications to be encrypted, then you can use self-signed certificates to easily encrypt those communication. It's not recommended for anything that is public facing, because the browser will tell you that it's not secure, or anything that's highly sensitive, high security environments. So if you're working for the Department of Defense, you probably don't want to be using this one. There are a bunch of Acme operators that support different providers of DNS. So it's really good for public-facing production deployments, especially when you are in the public cloud. It's not recommended for environments that don't have any DNS access, because it requires some DNS access for the DNS challenge. It's not recommended also for large deployments that are managed by different teams, because you will have to have multiple applications that will relate to the same operator that needs access to the DNS entry. So it's probably a bit more difficult to manage properly. And it's not also recommended for environments where your DNS API access needs to be limited. So again, for security reasons, things like that, you might not want to use those ones. There are many providers for that. So we have the Route 53 Acme operator already on CharmHub. There's the Namecheap Acme operator also on CharmHub, and HTTP Rec is a special one where it lets you provide an HTTP endpoint that will do its own thing in the background to update your internal DNS, for example. It's also easy to write other operators with the plugins from the Lego command that we mentioned earlier. The upstream project supports over 100 different plugins, so we've made it easy to create additional providers. There is also the TLS certificates operator, probably soon to be renamed and published, so keep an eye out for that. It's meant for high security environments where there is a manual certificates issuance process. So if you have your security team that needs to validate all the CSRs and manually approve those certificates, you can use this operator. So it will let the admin know that there is a CSR waiting for approval, and it will let you get that CSR, run it through your manual process, and put back the certificate inside the Juju environment. So it's not recommended for highly dynamic environments because of that manual process, but it's available for those highly secure environments where that manual process is required. So with that, thank you for taking the time today to listen to this presentation. If you have any question, again, I recommend that you take the time to ask them in the chat. Some of my colleagues will answer those. You can find me on the CharmHub Mattermost and Discourse at Gibourg. Here are some links that you will be able to find some more help on this. So the topic that we discussed earlier in the presentation. And also, there's the code that we did today is updated to the branch B exposed to the outside world on the upstream project.
Hello, everyone. My name is Massimiliano Gori, and I'm the Identity Product Manager at Canonical. As part of this session, I will talk about identity management and more specifically, the Canonical Identity Platform. Identity management means different things to different people. So we will start the presentation by explaining what does it mean for us. We will then discuss some of the major challenges companies face when configuring identity management for distributed systems. I will then use that to introduce the Canonical Identity Platform, and I will then hand it over to Natalia, who will show a demo of how our solution can be used to seamlessly secure any arbitrary endpoint of the sync chart. For us, the functional areas of identity management are the ones that are presented here on screen. So authentication, basically having users prove who they claim they are. Authorization, so what action can they do on which resource. Federation, it is the act of representing identity and access information across different services or system boundaries. This is the case of, for example, SAML or OpenID Connect. And finally, accounting or access governance. That is the act of reviewing whether a certain person was allowed to do a certain action on a specific endpoint. While these concepts are relatively easy for everyone to grasp, implementing them in a uniform way across distributed systems, being it VMs or Kubernetes, is extremely complicated. And that is mainly because of these three reasons. The first one is the fact that there are multiple complex standards that have ambiguous configurations. Being it OpenID Connect or SAML or even PKI, there isn't a one-size-fits-all, and there are multiple edge cases depending on the application. And for anyone approaching the topic for the first time, it can be a little bit daunting, and there is a lot of misinformation online. The second problem is and this is especially true for open source application, is the lack of single sign-on functionalities. Many open source applications, by choice or by limitations, they are unable to be seamlessly configured with centralized identity provider, and basically require the administrator to do so. And the third point is that even if you've done the right configuration and you've pressed the right buttons, the reality is that the security of your system really depends on certain minute configurations that you need to be knowledgeable enough about the system and about the standard to implement correctly. So this is why we decided to use the best of open source to create the Canonical Identity Platform. The idea is to build a common identity and access management framework that enables secure, compliant, and user-friendly access to our apps, devices, and infrastructure. We wanted it to be based on a couple of design principles. The first one was composability. We believe in separation of concerns, and the idea was to create a cloud-native platform made of individual services, that each one of them performing a single specific function. The second principle is that we wanted a single solution that is able to meet both enterprise and consumer identity use cases. The third is that we want to deliver a public cloud-like user experience. So abstract as much of the complexity away from the administrator. Finally, we want to adopt secure defaults without necessarily restricting customization from the user. And it is also important to respect the individual application identity and access models. It means that the idea is to centralize authentication and authorization only when it makes sense for the users. The results is a platform that fundamentally delivers on three main promises. The first one is the ability to configure single sign-on with OpenID Connect enabled identity provider like Azure AD, Okta, or Ping, just with one click or one command. And we will talk about that later. The second, and this is going to be the main topic of this presentation, is the ability to add authentication and/or authorization for all applications, regardless of their security models. As I said, not all applications offer federation endpoints or the ability to configure external identity providers. And what we were trying to do is effectively enable those for everything that can be put behind the proxy. And the third, since we're talking about distributed systems, is the ability to effectively use relationship-based authorization backend to express authorization. So looking at authorization instead of as a traditional tree, as a direct acyclic graph. Let's now take a look at our architecture. So as I said before, the aim is effectively to enable seamless access to three macro category of applications, which you find represented into the orange boxes here. Starting from the top, those are the classic set of applications that are unprotected by default. So the idea is if something can be put behind a proxy, then we should be able to add authentication. The second category of application are the ones that effectively support federation endpoints. And finally, we do have a couple of clients that, because they're legacy or because of the way that they are supposed to work, they won't either be behind the proxy or won't have the ability to accept any federation. And in this case, we are trying to enable the same using either certificates or like LDAP services. Now, if you look at our platform, there is the part in the dotted line which effectively is the core of it. We talked extensively about charms in the previous session, and the core identity platform will be delivered as a Juju bundle and includes a series of components. We use the Postgres charms that was illustrated in the previous talk as the default data backend for all of the components that we use. Starting from the bottom to the top, Hydra is the component that we use as our auth server. That means that is the component that issues tokens or JWTs to all the different components of our infrastructure. OpenFGA is another CNCF application that was developed by Auth0, and it is our authorization component, and it is the one that functions according to the relationship-based access control model. Kratos is the service that allows for authentication, and the idea is that it supports both local credentials for edge deployments or disconnected deployments, or also social logins or corporate identity providers like the one that you see listed in the blue square. Since all of these components are API-first backend services, we need something to tie them all together. And that's where the login UI component comes in, and as it effectively allows effective routing of the request between the different components. The admin UI is another component that allows the configuration of all the services that you see in this diagram. Now, outside of that dotted square, we also have AuthKeeper. That is our access control decision API, and that is effectively the component that allows the protection of all arbitrary application or APIs endpoints that are behind the proxy. Natalia will talk a little bit more or will explain how it works a little bit more in detail. And finally, GLOF is an LDAP interface that we have insisting on top of the same Postgres database. If we zoom into the architecture of today's demo, effectively, while there will be more charms deployed, the one that you will see in actions are effectively the ones that are presented in this diagram. So the proxy that we will use in this case is going to be Traffic, and we will dig a little bit deeper into its architecture. AuthKeeper will be what effectively will route the request to Kratos, which in our case is integrated with the Enter ID identity provider. So I will now pass it over to Natalia that will first give a little bit of an introduction about Traffic and our setup, and then show how that works on the command line and in the browser.
Hello, my name is Natalia Nowakowska. I'm a software engineer at the identity team at Canonical. I'm going to show how we can leverage Juju and charmed operators to simplify SSO integration and add it to the SymCase charm. We will see how we can configure an external identity provider and an access control to unprotected endpoints. But let's first clarify what we're about to see in the demo before jumping to the command line. You're going to note that Traffic plays an important role in our deployment. Traffic provides ingress control and live capabilities on Kubernetes. By that, we mean that the Traffic charmed operator exposes Juju applications to the outside of a Kubernetes cluster without relying on the K8s ingress resource. Instead, Traffic is instructed to expose the charmed applications by means of integrations with them. Traffic middlewares enhance its capabilities by tweaking the requests before they are sent to a service. There are several middlewares available in Traffic. Some can modify the requests, the others, some are in charge of redirections, others authentication, and so on. In this demo, we're going to make use of Traffic forward of middleware. The forward of middleware delegates authentication to an external service, which in our case will be AuthKeeper. If AuthKeeper answers with a 200 and something code, access is granted and the original request is performed. Otherwise, the error response from the authentication server is returned. If a charmed application is deployed behind Traffic with forward of middleware, any HTTP requests hitting its endpoints will be forwarded to AuthKeeper, the policy decision point. It will then check its access rules and decide whether a user must be authenticated to be allowed to reach the resource. If an endpoint is protected by the access rules and the user has previously verified his identity, AuthKeeper will ask Kratos if the cookie is still valid. If it's expired or the user is unauthenticated, AuthKeeper will execute an error handler. The user will be redirected to Identity Platform and asked to log in with an external identity provider. Upon successful authentication, AuthKeeper will send a 200 response to Traffic and the user will be let in. Along with that response, AuthKeeper will also transform the original request and send headers that the charmed application expects. And let's now move to the demo. We will start with having a quick look at the already deployed components in this model. It consists of Identity Platform charms, Postgres charms serving as their database, Traffic providing ingress, and an operator in charge of issuing self-signed certificates. You can also see many integrations between the charms, and I'll explain later what the purpose is and how they work behind the scenes. But let's first see how those components work together and what value they bring. Sync has a set of endpoints, some of which are protected by basic auth, while others are unauthenticated. We are now going to check one of the latter and see how we can add authentication to it through our enterprise identity provider. We can see that the application is up and running. But what if we wanted to hide that information from unauthenticated users? We could protect that endpoint with the identity and access proxy. To achieve that, we need some more Juju relations. And we'll need to wait for the charms to reconfigure for the changes to take effect. The charms are all green and active, so let's try to reach that endpoint again. And this time, instead of being shown the status of the application's health, we are redirected to the identity platform and asked to authenticate first. We can log in with Entra ID, and let's go through the authentication flow. All right. You can see that once I verified my identity with the external provider, I'm allowed to view the protected information. Let's check another instance. I'm allowed to see that endpoint as well because my session cookie is still valid. And let's now verify how that was made possible. In the backend, we have some configuration that makes all incoming requests go through a chain of traffic middlewares, one of them being forward off. Let's SSH to the traffic container. And check the routes responsible for that behavior. You can see the middleware is defined here in the auth-keepers root. And then referenced by the syncate strum. It means that any request hitting sync's ingress URL will go through an access control process. Traffic will call auth-keeper's decision endpoint and ask if the request should be allowed. Auth-keeper will match it with its access rules, and let's now see them. If the request needs to be authenticated, auth-keeper will call Kratos, the user management component, and ask if the session cookie it presents is still valid. If it's expired or it's not even in possession of the cookie, auth-keeper will redirect you to the identity platform's login user interface and give the possibility to authenticate with an external identity provider. You may still wonder how the Entra ID is integrated with the identity platform. Our team simplified the process, and it only requires a one-command Juju config to the Kratos external IDP term. I have specified it during the deployment, but we can always check it. So for incorporating Entra ID, you only need to provide its client's ID, secret, and tenant ID. The charms will take care of translating that into configuration and propagating across the deployment. Let's go to the presentation slides. Let me now show you how things work in the background. We have a number of integrations, but I wanted to call out the following three: forward off proxy, and IDP integrator. Next slide, please. The off-proxy integration gives you the possibility to pass URLs to be protected and endpoints you may want to make an exception for and allow access without the need of authentication, like an about page. You can also specify what headers should be returned to the original request, and all that information is passed by means of integration data. Forward off updates traffic routes with the middleware, default port sync as the application we'd like to protect, and of keeper as the policy decision point. The forward off and off proxy integrations set up the identity and access proxy. The Kratos IDP integrator registers the desired third-party identity provider with Kratos so that it can be used as an SSL authentication provider. As you could see in this demo with the Canonical Identity Platform and Identity and Access Proxy, you can add a protection to child applications that are non-OIDC compatible or don't offer any form of authentication.